Every night, when you look up at the sky, you can always see one star that's particularly bright, blue-white in color, twinkling near the horizon. That's Sirius, the brightest star in the night sky. With a magnitude of -1.46, it's twice as bright as the second brightest star. But what you see is not the whole story. Because Sirius is actually two stars. The one you see is Sirius A, a blue-white giant star with 25 times the brightness of our sun. But there's another one next to it, Sirius B, which you can't see. Not because it's too far away, its distance from Sirius A is only 20 astronomical units, about the same as the distance from the Sun to Uranus. You can't see it because it's too dim. Its brightness is only 1/400th of the Sun's, and it's completely overwhelmed by Sirius A's brilliance. It's like a firefly next to a flashlight. But that's not the point. The point is, it shouldn't exist at all. In 1844, German astronomer Bessel observed Sirius's trajectory and found it was wobbling. It wasn't moving in a straight line, but rather in an S shape, like it was drunk. Bessel said, "There must be something invisible next to Sirius, pulling on it." In 1862, American astronomer Clark finally found it. Using the most advanced telescope of the time, he saw an extremely faint point of light next to Sirius B. At first, scientists thought this was just an ordinary dim star. But after measuring it, they were shocked. Sirius B's mass is almost the same as the Sun's, but its volume is only the size of Earth. Wait a minute. Something as heavy as the Sun compressed to Earth's size? How dense must that be? Scientists calculated 1 ton per cubic centimeter. 1 teaspoon of Sirius B material weighs 1 ton. A sugar cube-sized piece could crush an elephant. This is a white dwarf, the corpse of a dead star. The core collapses, the outer layers are thrown off, and the remaining core is compressed to the limit. Electrons and atomic nuclei are squeezed together, reaching a density 1,000,000 times that of Earth's material. Surface temperature of 25,000 degrees, 4 times hotter than the Sun's surface. But because its volume is so small, its total luminosity is only 1,000th of the Sun's. And it's still cooling. In billions of years, it will become a black dwarf, the coldest, hardest, deadest rock in the universe. But that's not the most terrifying part. The most terrifying part is that someone knew about its existence 3,000 years ago. In the 1930s, French anthropologist Grial came to Mali in West Africa. There was a tribe there called the Dogon, living a lifestyle that was still in the Stone Age. No writing, no telescopes, no scientific instruments. But Grial discovered they had an extremely complex system of astronomical knowledge. The Dogon told him, Sirius has a companion star called Ptolo. This star is very small but extremely heavy, the heaviest thing in the universe. It orbits Sirius once every 50 years. Grial was stunned, because this was completely correct. Sirius B's orbital period is 50.1 years. Its density, white dwarf material, is indeed the densest normal matter known, with only neutron stars being denser. How did the Dogon know this? They said, long ago, people from Sirius told us. In 1976, writer Robert Temple wrote a book called The Sirius Mystery. He said the Dogon's knowledge proved aliens exist. Thousands of years ago, an alien civilization from Sirius visited Earth and passed this knowledge to the Dogon. This book sold millions of copies. But scientists said, wait a minute. In the 1990s, astronomers reinvestigated. They found that Grial's first visit to the Dogon tribe was in 1931. Sirius B was discovered in 1862. That's a gap of 69 years. During these 69 years, European colonizers, missionaries, and merchants flooded into West Africa. The Dogon might have heard about Sirius B from them. Moreover, Grial's investigation notes show that after he told the Dogon that Europeans had discovered Sirius had a companion star, the Dogon began saying our ancestors knew this long ago. This is typical cultural contamination. External knowledge gets absorbed into local legends and then claimed to be passed down from ancestors. And the Dogon's account wasn't completely accurate either. They said Ptolemy has a satellite. Sirius B has no satellite. They also said Ptolemy is red. Sirius B is white. With a surface temperature of 25,000 degrees, it couldn't possibly be red. So the alien theory might just be a beautiful misunderstanding. But that doesn't matter. What matters is Sirius B itself. Imagine standing on Sirius B's surface. The gravity is 350,000 times that of Earth. If you weigh 70 kilograms on Earth, on Sirius B you'd weigh 24.5 million kilograms. You'd instantly be crushed into a meat pancake as thin as paper, then immediately vaporized due to the 25,000 degree surface temperature, turning into plasma. But that's not the most terrifying part. The most terrifying part is you can't fall through. Because a white dwarf's surface isn't made of ordinary matter, it's degenerate matter. Electrons are compressed to the quantum mechanical limit. The Pauli exclusion principle states that two electrons cannot occupy the same quantum state. So electrons desperately resist compression, producing degeneracy pressure. This pressure is 10 billion times harder than steel. You cannot penetrate it. Even a meteorite impacting at 1/10 the speed of light would only splash plasma sparks on the surface and bounce off. A white dwarf's surface is one of the hardest things in the universe. Only neutron stars are harder. But what about Sirius A? That blue-white giant you can see is in its prime. Age, 240 million years. Surface temperature, 9,900 degrees. Mass, twice the sun's. Brightness, 25 times the sun's. Its lifespan? Scientists calculate it can live another 600 million years. Then, when its hydrogen fuel is exhausted, the core will begin to collapse. Temperature will rise and helium burning will begin. The outer layers will expand into a red giant. Its volume will expand to swallow its current orbit. Any planets would be engulfed inside the star and vaporized. Then the outer layers will be blown away, forming a planetary nebula. The core will collapse into a second white dwarf. By then, the Sirius system will become a binary white dwarf system, two dead stars orbiting each other, slowly cooling. Eventually, billions of years later, they'll become two cold, black cosmic corpses. But right now, Sirius is still very bright. What if it replaced the sun as our star? Distance remains the same 150 million kilometers, but brightness is 25 times the sun's. Day 1, Earth's received solar radiation suddenly increases 25-fold. Global average temperature skyrockets from 15 degrees Celsius to 60 degrees Celsius. The polar ice caps begin melting. Equatorial regions exceed 80 degrees Celsius. All human habitats become ovens. Day 3, the ocean surface begins boiling. Massive amounts of water vapor enter the atmosphere, creating a runaway greenhouse effect. Temperature continues rising. Atmospheric pressure begins increasing. Day 7, surface temperature breaks 150 degrees Celsius. All plants wither and spontaneously combust. Oceans evaporate. The atmosphere fills with water vapor. Atmospheric pressure is 3 times the original. All humans are extinct. 1 year later, Earth becomes Venus 2.0. Surface temperature, 400 degrees Celsius. Atmospheric pressure, 90 times Earth's. The sky is perpetually covered by thick clouds. The surface is a complete desert. All water has either evaporated into the atmosphere or been broken down by ultraviolet radiation, with hydrogen escaping to space. 10 years later, even the atmosphere begins to be stripped away, because Sirius not only emits more light but also more ultraviolet radiation. This high-energy radiation shatters atmospheric molecules, which escape to space. 100 years later, Earth becomes a barren rock. No atmosphere, no oceans, no life. The surface is baked into glassy lava. This would be humanity's fate if our sun were replaced by Sirius. But fortunately, Sirius is 8.6 light-years away from us. This distance is just right, close enough that we can see it, far enough that it won't kill us. If it were closer, say 3 light-years, Sirius's ultraviolet radiation would tear apart Earth's atmosphere. If it were farther, say 20 light-years, it wouldn't be so bright. It wouldn't be the most conspicuous star in the night sky. It wouldn't have been given mythological significance by ancient peoples. The ancient Egyptians called it Sopdet, a harbinger of the Nile's flooding. The ancient Greeks called it Sirios, meaning scorching. The ancient Romans believed it brought disease because it rose in midsummer when plagues were common. The Chinese called it Tianlang, an ominous star associated with invasion. All civilizations noticed it because it was so bright. But no civilization knew it was actually 2 stars, one alive, one already dead. One scorching hot, one ice cold. One you can see, one forever hidden. But there's an even more eerie fact. Sirius is 8.6 light-years from Earth, meaning light takes 8.6 years to travel from Sirius to Earth. So in January 2026, the Sirius you see is actually Sirius as it was in July 2017. What Sirius is doing right now, nobody knows. Maybe it's erupting. Maybe it's been hit by something. Maybe Sirius B has already siphoned off its material. But we won't see it until 2034. If Sirius suddenly went dark right now, we'd still see it shining for another 8.6 years. Then one night, it would suddenly disappear. This is the curse of the speed of light. In the universe, there is no now, only the past. Every star you see is its history. Betelgeuse in Orion is 640 light-years away, you're seeing it as it was in 1386. The Andromeda Galaxy is 2.5 million light-years away, you're seeing it from before humans had evolved. And the most distant galaxies in the universe are 13 billion light-years away. You're seeing them